Alright, so let's talk about domain and range. So we're going to take two colors here. I'm going to use orange and green. The first thing that we're going to do is highlight the domain. The domain is the set of all x values within a relation or a function. So we're going to do that in orange, and I hope this shows up well. That's going to be all the x values within the function. Again, the domain is all the x values, so that's going to start at -2. And it's going to go all the way over until the x values stop at 6. Now after that, what we're going to do is we're going to highlight the range. The range is going to go from this point right here up to about here. And just as a reminder, the range is the set of all y values within a relation. Now we can write both the domain and range as intervals, which means we can use set or interval notation. So let's do that. So the domain is going to go from -2 to +6. And the set notation for this, because we have two finite bounds, these are going to go on the outside. And we're going to surround our variable with less thans. In this case, we surround them with less than or equal to. This is different from increasing and decreasing. This is different from increasing and decreasing because, for example, -2 and +6 are actually included in our domain, because there are points at -2 and +6. The x value of -2 has a point, the x value of +6 has a point. And it's not just that they're on the x-axis, it's that there is a point somewhere on the x value of -2. It could be down here, it could be up there, it doesn't matter. As long as there is a point where the x value is -2, that's part of our domain. Same thing for 6. So because they are included in our domain, we're going to use less than or equal to's, and we're also going to use brackets in the interval notation. Okay, now with the range is actually going to go from here to here. Now note that the graph is going up by a half instead of 1. And the way that we know this is because there are 4 lines between 0 and 2. So 1 is actually right here, for example. So right here, this is going to be -1. And so we're at about, I'd say, -1.4. And we end up at +1.4. Because again, 1 is right here. So we end up at, with an interval from -1.4 to +1.4. And again, these are y values. Now we have two finite bounds once more, so they're going to go on the outside. But in the middle, we're not using x values anymore. We're using y values, so we're going to put y here. And once again, we're going to use some brackets for our interval notation, because both of the bounds of our range are included. Now note, domain usually goes from the left end to the right end. Domain usually goes from the left end and to the right end. And the range usually goes from the minimum, usually the absolute minimum, to the absolute maximum. And that does hold true right here. So let's look at this function here. The left end doesn't really exist, so the left end is going to be -infinity. The right end doesn't really exist. The right end is +infinity. The absolute maximum here doesn't really exist. Does not really exist, so there is none, because it's technically positive infinity, right? We just can't express that the absolute maximum as a positive infinity because it's not really a maximum. It's not like there is an upper limit, so none is an answer that you might see. It's really positive infinity. Like, that's what it really is. But there really isn't a formal absolute maximum. The absolute minimum, however, does exist, and the reason why we can say that it does exist is because the graph doesn't keep going downwards. So the graph stops at around here, and I'm highlighting it using my range color so that we can start the range at that point. So I remember that we labeled, keep in mind that's -5. This point right here, we've labeled this in the past as -5.25, comma -2.8. So we're going to stay consistent with the other sets of notes here and say that the absolute minimum is this point, -5.25, comma -2.8. And the minimum y value is that -2.8. So this is the minimum y value. Alright, so now let's put this into word form, set notation, and interval notation. So the domain is actually going to go, let's see, it's going to start all the way left, and it's going to keep going all the way right. It's going to go from our left end, which is effectively negative infinity, to our right end, which is effectively positive infinity. From negative infinity to positive infinity. Now, because we have two infinite bounds, we don't want to include infinity in our set notation. So when we have an infinite bound, we either want to write it as a single inequality if there's one infinite bound. But if it's infinite on both sides, then we write this as all real numbers. We write this as all real numbers. Now the interval notation is boring, it's just negative infinity to positive infinity, but because they're infinities, we can't include either of them because they're not numbers. So we have to use parentheses. We can never put brackets on infinities, ever. Now for the range once again, the range does go all the way up, but it doesn't go all the way down. It starts here at that -2.8 minimum y value. So our word form is going to be from -2.8 to positive infinity, because it starts at that -2.8, that minimum y value, and then it goes all the way up. Our set notation, because we have one finite bound and one infinite bound, we're going to write this as a single inequality. And again, we're going to use y because this is range. Now we're going to want to say that y is either less than or greater than this -2.8, depending on what the range is doing. So because the range is going up, we're looking at all of the values greater than -2.8. And so we're going to use greater than or equal to -2.8. And that's how we express this. We don't want to put stuff like negative infinity on the other side. That doesn't work. Like, we don't want to say like, we don't want to put like infinity, yeah, blah blah blah, like that. That's not good. This is not a good way to write it. This is a much more correct way to write set notation with one infinite bound. Now the interval notation is once again very boring. It's -2.8 to positive infinity. But that's honestly nice. Like, interval notation is nice for infinite bounds because we can actually use infinity in the notation, and it's much easier to convert from word form to interval notation than it is to go from word form to set notation. With one caveat. Do we include the -2.8? And the answer is yes, because the graph does in fact reach that y value.